Hey everybody, this is Mr. Beckstrom, and today we're going to take a look at section 1-1. This is on ratio and proportion. I will show you a couple of the formulas and concepts, and then we'll do a couple of practice problems as well. And when we get to those practice problems, if you can go ahead and pause it and try it before we do it, that's usually one of the best ways to learn. Even if you don't get it, I'm going to go over the solution afterwards. All right, so first of all, what is a ratio? And this is on page 6 at the top. I'm just going to read it. But it says, a ratio is a comparison using division of two quantities of the same kind, both usually expressed in the same units. For example, the steepness of a hill can be written as the ratio of its height to its horizontal extent. So we're talking about a fraction here, usually written as a fraction. We can also write it a couple of different ways, but it is going to be normally in the same units. So for example, with the one that they just gave, the steepness of a hill, which is rise over run. So for example, let's say we had a hill. It's a horrible hill. Well, let's say the distance from the bottom of the hill to the top of the hill was 300 feet. And the distance from the bottom of, the hill, horizontally is 300 feet. And vertically is, let's say, 600 feet. 600 feet. I'll do a little check for feet. And if we said that what is the steepness of this hill, or really if you've taken any pre-calculus, what is the slope of this hill, we know that that's the vertical distance over the horizontal distance. So in this case, it would be 600 feet, because that's our vertical distance, and that's what goes on top for steepness, over 300 feet. For our horizontal distance, and we can write that as 2 over 1. That's what that reduces down to, because 300 divides into 600 twice, and 300 divides into 300 once. If you need a little bit of help with simplifying fractions, let me know. And I'm also going to do it in my calculator. Now, you do need a calculator for this class. You don't necessarily need the TI-84, the one that I'm using here. But in order to simplify fractions, most calculators can do this. And by the way, the calculator that I strongly recommend for this class for you is the TI-30 XS Multi-View. Make sure it has the word multi-view in it. And those can be found at the bookstore on Amazon. They're generally $20 or less. All right. So let's kind of go in here. So if I did 600 divided by 300, and I got a number 2, and if I want to convert that to a fraction, well, really, since it's over 1, it just leaves it as 2. So we can write 2 over 1. So this one's not going to actually put it into a fraction form, just because it's over 1. But let's look at one that will. Let's say I have 10 divided by 15, and I want to reduce that. First, it's going to give me a decimal of that, and then if I hit math, fraction, it will then reduce that to 2/3 for me. So as long as there's not a 1 in the denominator, it'll show up there. This is an easy way for us to simplify a fraction without having to do like a prime factorization. All right. So that is this. So let me give you a couple of common ratios that we use in the technical fields. One of them is the gear ratio. That's the number of teeth on the driven gear divided by the number of teeth on the driving gear. And then the other one is a compression ratio, which is mainly used in like engines for cars and other vehicles. And that's the expanded volume over the compressed volume. So at this point, I'm going to give you an example that I want you to go ahead and pause and try on your own. So I said, what is the gear ratio? So what is the gear ratio? And here's my gears. Oops. There's my gears right there. And on the driven gear, let me go ahead and driven gear is equal to A, which is equal to 42. And on the driving gear, which is equal to B, is equal to 6. Now let's just say that these are the number of the gears. The driven gear is A, that's this gear, and the driving gear is B, which is this little gear. And on the driven gear we have 42, and on the driving gear we have 6. So what would the gear ratio be? Go ahead and pause and try that now. Alright, so all we're doing is plugging this in and then simplifying. So this is going to be equal to the number of teeth on the driven gear, which is 42, all over the number of teeth on the driving gear, which is 6. And we can reduce because 6 goes into both of these numbers. It goes into 42 7 times, and it goes into 6 1 time. So this would be a 7 over 1. And if we were to put this into our calculator, it would just give us 7. But remember, we can write any number divided by 1. All right, so let's go ahead and erase that. And try another one here. This time I'm going to give it to you a little bit different. Let's say our gear ratio is, so our gear ratio is equal to 5 over 2, 5 halves, and our driving gear has, how many teeth would that have? Has 20 teeth. How many teeth does our driven gear have? All right. So try this one here, and we'll see if we can figure out how many teeth this driven gear has. If the driving gear has 20 teeth, and we know the gear ratio is 5 over 2. That means 5 driven teeth for every 2 driving teeth. All right, go ahead. All right, well, I'm going to kind of set this up just like it looks up here. So we know the gear ratio is 5 over 2. So I'm going to write that down, 5 over 2. Remember, just like this formula over here, so this is equal to the number of teeth on the driven gear, which we don't know, so I'm going to call that X, over the number of teeth on the driving gear, which I do know, which is 20. So I've actually set up a proportion, which is what we're also doing in this section here. And to solve a proportion, we cross multiply and then we divide. So first you cross multiply either way. So I'm going to do X times 2. So this is going to be 2x is equal to 5 times 20, which is 100. And then you're going to divide. Whatever number you have multiplying your variable, that's what you divide by. So right now we have a 2, so I'm going to divide both sides by 2. That will get rid of my 2's over here, and then x is equal to 100 divided by 2, which is 50. So that means I have 50 teeth on my driven gear. All right, so try some of the examples in my math lab and also in the book. Make sure that you're understanding this, and then we'll move on to proportion. All right, a proportion is an equation stating that two ratios are equal. So how do we set up a proportion? Well, we could set it up like this. 1/2 is equal to 2 over 4. And the question is this in proportion? Well, in order for this to be a proportion, both sides have to be equivalent. And one way I can check that, if I didn't know that 2/4 was equal to 1/2, is I could look at each side and make it into a decimal. So the left side here is just going to be 1 divided by 2, and that's equal to 0.5, and the right side is 2 divided by 4, and that's equal to 0.5. So this is a true proportion because both sides are equal. Let's take a look at one that's not. Let's say I have 1/3 is equal to 2 over 7. Well, if I did the same thing with my calculator here, 1 over 3 is equal to 0.333, and then the other one was 2 over 7 is 0.28. These two are not the same, therefore this is not a proportion there. So this is how we do a proportion. Now normally the way we're going to be doing proportions is one of these values is going to be a variable, and then we're going to solve for that variable. And we're going to be using the cross product rule, which we just did with the ratios earlier, but here is the cross product rule. And it says that if we have A over B is equal to C over D, and these can be any numbers or values, then you can cross multiply. Then the product of these two values is going to be equal to the product of those two values right there. All right, and let's go ahead and try an example here. So let's say I had 3 over 5 is equal to x over 50. Let's say we set up this proportion, which remember is just two ratios that equal each other. How would we solve for x? So go ahead and pause the video and give it a try. All right, so first we're going to cross multiply. Remember, I can start either way first. This time I'll go the 3 and the 50. So 3 times 50 is 150 is equal to, and 5 times x, we can just leave that as 5x. So this is going from here to this step here. Now to actually solve for x, I'm going to have to divide by whatever number I'm multiplying my x by. So in this case it's the 5, so I'm going to divide both sides by 5. And finally, x is going to be equal to 150 divided by 5, which is, I think it's 30. But let's just make sure here. 150 divided by 5 is in fact 30. So that would be our answer. And that means that I can now rewrite this proportion as 3 over 5 is equal to 30 over 50, and if I were to find the decimal approximation for each side, it should be 0.6. It should be the same thing on both sides. All right, let's take a look at a little bit more complex of a problem. All right, so here it says for a house building job, 2.5 cubic yards of concrete is needed for every 50 square yard surface of the driveway. So how much concrete will be needed for a 185 square yard driveway? So let's kind of try to first draw a picture and break this down and try to understand what they're asking, because a lot of times we see these word problems and we have no idea where to go. So I'm just going to draw like an arbitrary driveway. And I know that this entire driveway here is 185 square yards. And I can write that as yards with a little 2. That means square yards. And I also know that for every 50 square yards, so some portion of this, some portion that we're going to call 50 square yards, I'm going to need 2.5 cubic yards of concrete. Now cubic is written with a 3, So this is like a three-dimensional, so it's got like a length, a width, and a height. These like bags of concrete here. And this is a surface with just like a length and a height, but remember there's going to be a thickness to this driveway as well. That's why we're going to need a lot of concrete. And let me do that. So the question is, how much concrete am I going to need? All right, so let's go ahead and set this up as a proportion. So what we want to do is we want to set the ratios up with things that we know, and then the variable that we want to find. So I know that for every 2.5 cubic yards, or covers 50 square yards. So I'm going to do for every 2.5 cubic yards, and this is going to be the left side of my proportion. So I'm also going to put on the top here 50 square yards. Right? Because we have like a direct relationship between these two things. So they're both going to go on the top of my ratios. Now remember, if possible, I want to keep the same units in the specific ratios here. So I want to keep the cubic yards over on this side, and I want to keep the square yards over on this side. So for 2.5 cubic yards, we know we have the 50 square yards there. So the question is, how much are we going to need if we have 185 square yards, right? Because remember, yards. Don't forget, we want to keep the same units, so we want to keep the square units on one side here. And let me, I am not drawing this very neat. My apologies. Alright, so this is how we can set it up, and then remember what we're going to do is we are going to cross multiply and divide. So x times 50, we can just write that as 50x is equal to, and then 2.5 times 185. We'll use our calculator for that. 2.5 times 185. And that's 462.5. So 462.5. And now remember, we're going to divide both sides by the number that is multiplying our x. So we're going to divide both sides by 50. And that's going to give us x is equal to 462.5 divided by 50. And that's 9.25. 9.25. Now remember, for buying bags, let's say we're buying 2.5 cubic yard bags of this concrete, we can't buy a quarter of a bag. So if we're asking how many bags that we're going to need, that would be, we would round up to the next number 10. But this says how much concrete will you need for that, and that would be 9.25 cubic yards of concrete. Right? All right. I hope this helps, and I want to look at one other problem here. That's actually it for this section. So go ahead, start to work on the homework problems. There's also some other YouTube videos and PowerPoints that are in the Moodle section, and please let me know if you have any questions. Thank you, and have a great week.